There's another thing that can go wrong with hash tables I'd like to describe, which is what happens when you add a mutable key. Now, before I could tell you what a mutable key is, I need to tell you about what an immutable data type is, and contrast that with a mutable data type. So an immutable data type is one where once you instantiate the object, it cannot change in any observable way. It's actually a fairly subtle definition, and I'll do a couple of kind of silly examples in a moment, or four. But before we get to the silly examples, let's consider a simple one. So this date class that I've defined here, it is an immutable class. When I instantiate a date, I can never change anything about the date again. It has four properties: month, day, year, and contrived. But once a date is created, from an external observer's perspective, there's no way you could change it. One of the ways that I've done this is I've used here the final keyword. And what final does is it says this memory box's bits can never change. It can only be set once, either in the constructor or in an initializer, which is where you put up top like contrived equals true. Okay, so remember that. Mentioned this like maybe once or twice before, that you can put an equals up here, or you can do it down here in a constructor. Okay. So this right here is an example of an immutable class. Other examples would include strings in Java, capital I integers in Java. By contrast, a mutable type is one where an instance can change. So for obviously an array deck, it can change. Once you create it, it's empty at first, and then you can add items. So it is mutating. Likewise, a percolation object, which we have on a percolation homework, that one you can open sites and it will change over time. Okay. So this final keyword I mentioned, I haven't seen it before, but it's one way that we can try and enforce immutability. But I should note that final is not sufficient or necessary for a class to be immutable. So for example, if all these variables were private and none of them were final, it would be immutable, because when someone creates the date, they would have no access to the variables. Okay. So I'm going to ask you a few questions here. This is kind of a silly exercise. It's a puzzle, which is, are the Pebble, Rock, Roxbox, and Secret Roxbox classes immutable? Meaning, if I instantiate a Pebble, could I ever change it? If I instantiate a Rock, could I ever change it? A Roxbox, and so forth. So consider these examples, and if you can, construct some code or some idea of code where once instantiated, you could make the object mutate. This is a pretty hard thing to be dropping on you in the middle of a lecture, I'm going to note. It's kind of a fun puzzle. I'm just mentioning it to let you know that immutability is a subtle point. Okay, so try and figure them out. Pause this video, think about it, or just get spoiled in a moment. Okay, so it turns out Pebble is mutable. I can create a new Pebble, and then I can simply set its weight to 2. So in that sense, it is mutable. It's not immutable. I can create a Pebble and change its weight. Rock, by contrast, is immutable. Once I set a rock's weight, there's no possible way that I could ever change it again. So there's no mutation possible unless you use the reflections library. I'm not going to talk about that here, but it allows you to get around, for example, the various keywords. So with reflection, it may be possible to break some of these rules. So I'm not going to count that. Like for any normal code that's not using the special library, there's no way to mutate a rock once it's created. Now you might say this weight seems useless. I could never access it. If you wanted to be able to see the weight of the rock, you would want to have a separate method that can return a copy of the weight. But here, this rock is immutable. Okay, how about Roxbox? Turns out a Roxbox is mutable. For example, if I create two rocks, R1 and R2, with size, or what do we call it? Weight, 10 and 20. And then I create the array of R1 and R2. If I pass the rocks array to the Roxbox object here that I'm creating, RB, I could then reach in, because this variable is final, and get rocks. And then I could say rb.rocks1 equals null. Now you might say, I think that's cheating. But if we think very carefully about what final means, final just means that the rocks variable can never change. Remember that rocks is a memory box with 64 bits in it, representing the address of an array. We're not changing those 64 bits. Instead, we're traveling to that object, and then following rb.rocks1, and there's no special keyword in Java to say, not only is this variable final, but so too are the references within this variable. That's not a thing that Java allows, so we're stuck with this vulnerability potentially. One possible way to fix that is to make this variable private. And so that was the secret Roxbox class, same as Roxbox, but not secret. But even this one And this is where the point is that mutability is very subtle. Even this one is vulnerable to a certain type of attack, I guess I'll call it. So as before, I could create an array with rock 10, rock 20, and then pass that array to the secret rocks box. It keeps a copy of that reference right here in this variable called rocks, and you would think everything's fine. However, the code that handed the rocks, or this rock array, to the secret rocks box constructor, it could then take its own copy, remember it has its own pointer, and say, rock 0 is going to be now rock minus 999, okay? And that would be visible from secret rocks box. This would be some kind of annoying midterm problem. We could do some box and pointer diagrams. Hopefully the general idea is there, just to say that immutability can be very subtle and sometimes tricky. Now I'll talk about why it's useful in a moment. Okay. Now I will note that there is a way to prevent the secret rocks box attack. If you'd like, you can try and consider a way to get around this. If you want, you can pause and think about it. Or I'll just say the way that you would often do this is you create a copy of the array that gets passed to you. So when someone gives you an array of rocks, you make your own copy to your own personal array that is totally distinct from the original one. So I'm copying the reference that tells me where rock 0 is. I'm copying the reference that tells me where rock 1 is. And this call now will have no effect because this secret rocks box made its own copy. So if you were to look at industrial strength code, they might do something like this because they figure we want to be very safe, or maybe they don't because they don't want to waste the time and the memory to make your own copy. It just depends on the application. Okay, so what is mutability and immutability all about? Why am I bringing this up? So one advantage of an immutable class is that there's not much to think about. It means that whenever you are given an object, there's no way it could ever change, right? So for example, the string class in Java is immutable. It has a character at, a compare to, a concat, a split method, and no matter what you do, once you have a string, these functions will always return the same variable no matter what kind of trickery you pull, and therefore it is immutable, and that just means it's easier to reason about, right? Whereas these earlier classes, like the original secret rocks box, there is the possibility of a very subtle bug happening to the user. Like they don't mean to do this horrible thing, they just accidentally in the course of writing code do it. You could run into trouble. So a truly immutable class, it just avoids an entire class of errors, but there's of course a disadvantage, which is that you can't mutate the object. So if you want to add a letter to the end of a string or change one character, you got to make a whole new string. Okay, so that's mutability. And we'll talk a little bit about this later when we talk about software engineering, but just wanted to get that idea across, start letting it stew in your brain, and we'll see what it means in the context of hash tables in just a moment.